afternoon, everyone. Thank you for joining us today. My name is Andrea Baer, and I'm the Climate Services Program Manager for the Western region. And I am part of the group that has created this little climate seminar series for you all this year. And today we're happy to have Melissa Ou and Brad Pugh from CPC. Melissa and Brad are two of the key developers of the 8 to 14 day hazards outlook, and they're going to talk to us about the outlook in general, along with some of the tools that they use, including their extremes tools, and also what they're working on for the future of the product and for tools. So we're going to have them go through both of their presentations, and then we'll save questions for the end. But feel free during the presentation to, as your questions pop up in your mind, put them in the chat box. And Jenna Myers from the Climate Services branch will facilitate that at the end of the briefing. So without further ado, I will turn it over to you, Brad, and thank you very much.
All right, thanks, Andrea, and thanks everybody for joining us today and giving Melissa and I the opportunity to share one of our bread and butter operational products at the Climate Prediction Center, the Week 2 U.S. hazards. So here's the outline of my presentation. I'll give a brief background on the Week 2 hazards, the variables that we forecast for, and also the criteria we use. An example of the map itself and a discussion that goes along with that outlook map. And then 3 successful examples of high impact events that we've had this past year. All right, so the motivation for the Week 2 U.S. hazards was to link climate to temperature and precipitation related Week 2 hazards. Those climate represent ENSO, Madden-Julian oscillation, and also blocking regimes. Kind of using that the background to tie those into Week 2 hazards. Also provide various stakeholders context to the timing and location of most likely hazards. And another important motivation here was to provide adequate lead time of more than a week to aid in preparation to mitigate impacts, for the public awareness, but also forecasters, that are more in the shorter time scale, in the 3 to 7 day or even shorter than that. Just make them aware of potential hazards that are on the horizon at 2 weeks in advance. So here's just some background on the Week 2 hazards. It's released each weekday around 3 o'clock Eastern Time. It's primarily a probabilistic format for the variables temperature, precipitation, and wind. Since the probabilistic format is obviously more appropriate than deterministic for longer leads. There are a couple of categorical forecasts, such as flooding and flash drought hazard that's in the works right now, and hopefully that'll be coming out by the next warm season. And the reason the flooding and flash drought hazards are categorical is we don't have the adequate tools right now to produce probabilistic flooding or flash drought outlooks at this time. And forecasters post hazards which are most likely to be a risk to life and/or property. The season, time of year, and antecedent conditions are important to consider. And forecasters rely upon statistically post-processed ensemble model output to define a slight, moderate, or high risk of a hazard occurring. All right, so here are some of the temperature hazards that we post. Top one there, excessive heat. which obviously that's a major one during the summer with heat waves throughout, all of the lower 48. And the criteria used are aiming to meet like heat advisory threshold. And those do obviously, they vary by region and time of year. Much above normal temperatures. The criteria for that is daily maximum temperatures exceeding the 85th percentile of the climatological distribution, and also deemed hazardous, and that varies by region as well. And then much below normal temperatures, when daily minimum temperatures, that should be below the 15th percentile of the climatological distribution and deemed hazardous. So looking for minimum temperatures in the lowest 15th percentile, and also that would be considered hazardous. So like an early frost freeze, record cold outbreaks during the winter, those type of cold events. So in terms of precipitation, the heavy precipitation hazard is focused on 3-day total precipitation amounts exceeding the 85th percentile and deemed hazardous, typically using 1 inch for the CONUS, but that also varies by region. And I did put this in italics here, the exceeding the 85th percentile. That's very important because some parts of the country, such as the Gulf Coast, the Pacific Northwest, 3-day precipitation amounts of 1 inch are, would not be considered hazardous, and not too far off from climatology during the wettest times of the year. Heavy snow with amounts that are forecast to be near or reach winter storm warning criteria. And high winds, sustained wind speeds reaching the 85th percentile and 25 to 50 miles an hour. And both the heavy snow and high winds, those hazards do also vary by region. Obviously, heavy snow, the winter storm criteria is much higher across the Midwest than the Southeast. So next slide here, this is just an example of the map. If you go to our homepage, click on the week 2 hazards, and if you were to look at the risk of hazardous temperatures, this is from last week. So at that time, we were posting a slight risk of excessive heat for parts of the Pacific Northwest, Central Valley of California, and the desert Southwest. And on the right-hand side is an example of the discussion that we post alongside the map depiction. So we have a synopsis, which is more of a summary, tends to be a little more non-technical, bullet points of the hazards, and then a detailed summary, which is more detailed on the tools used. And we also try to tie it into potential impacts as well. So moving on now to 3 examples of successful forecast of high impact events that we've had this calendar year. 2 are temperature related and 1 precipitation. First one here is the major heat wave that affected the western U.S., especially the Pacific Northwest during late June. So we had excessive heat warnings posted for nearly all of Washington and Oregon, much of Idaho, parts of California and Nevada. The date was June 26th. So next slide here is daily and monthly and all-time record highs So I won't go through all these, but just to just to highlight how record-breaking this heat wave was. There were numerous all-time record highs met, especially across Oregon and Washington. And also like to draw your attention here to on the right-hand side here, the margin that the observed maximum temperatures beat the old record. You can see the margin here is a really remarkable record-breaking heat wave. The margin as high as 6 to 11 degrees above the previous record. And some of these period of records go back pretty far here. Downtown Portland, for example, back to the late 1800s. Salem, Oregon, back to 1893, and the all-time records on June 28th were just 8 to 11 degrees above the preceding record. So just quite remarkable what occurred back in late June there. Just check out, see how we did here. If we go back about 8 to 10 days in advance, we had a moderate to high risk of excessive heat posted for much of the western U.S., including a high risk for many of those areas that experienced the record-breaking temperatures. So a couple of the tools we use to forecast this excessive heat event was our GEFS and European reforecast tools. And this is the probability of maximum temperatures exceeding the 85th percentile. So you see some high probabilities here, up to 60% in the GEFS. On the right-hand side is the European, which had slightly larger probabilities throughout the West, and also a little bit more widespread on the spatial scale. So forecasters see these high probabilities above 60%. That's a very strong signal for very high temperatures. So that was a good signal to forecasters. And also we use 500 millibar height anomalies. On the left-hand side is our week 2 manual 500 millibar height blend. So during that week, June 26th through July 2nd, had positive 500 millibar height anomalies as high as 90 meters coastal Pacific Northwest. So for this time of year, late June, beginning of July, it's a very anomalous ridging over the Northeast Pacific and along the West Coast. And to go along with that anomalous ridging, the probabilities for above normal temperatures were quite large, up to 60, 70% over the Western U.S. All right, so on the other side here, I had a big Arctic outbreak, if you remember, back in February, especially across the central and southern regions of the country. Right at the mid part of February 13th and 14th. And this is a tweet that the Climate Prediction Center sent out. It was eight or 9 days in advance. Showing the high risk for much below normal temperatures across the Great Plains, Mississippi Valley, Ohio Valley. On February 14th, the observed minimum temperatures had lows down to 0 down into the central southern plains, and hard freeze all the way down to the Rio Grande River. And minimum temperature anomalies 15 to 30 degrees below average on February 14th. So 10 to 11 days prior to this Arctic outbreak. We were seeing signs of this. Initially, we were a little more focused on the east central part of the country, but we did have a moderate risk of much below normal temperatures here across the Great Plains. A couple of days later, it was becoming more evident among the model guidance and associated tools that the Arctic air outbreak would be focused more to the lee of the Rockies across the Great Plains. So we did have a high risk of much below normal temperatures for this part of the country. And on that date, here's the 500 millibar manual blend. So obviously this is a very strong signal for an Arctic outbreak, with the blocking at the highest latitudes in North America, full latitude ridge offshore the west coast to the Bering Strait. So that helped to push that Arctic air well to the south, even down into northern Mexico. And obviously this had very high impacts to Texas, especially. So here are the GEFS and European reforecast tools 8 days in advance, showing probabilities as high as 70 to 80% that minimum temperatures fall in the lowest 15th percentile. And I didn't include it here, but we also, the tool also gives us the chance to see what the probabilities for near record cold is. And there was also a pretty strong signal for the record cold to occur across the Great Plains in Midwest around February 13th and 14th. Also, this tool allows us to pick out probabilities of differing values. For example, probabilities that minimum temperatures would be below 32 degrees. So you can see here the tool was showing more than a 40% chance of a freeze all the way down to the Rio Grande River on February 13th. So that verified quite well. And finally, one example for heavy rainfall occurred back at the beginning of March. This was the 7-day observed precipitation. So had a swath of 2 to 6 inches of rainfall extending from the Ohio River south westward towards Arkansas, northern Louisiana. Picked this one out because early spring's always a potentially high impact time of year for flooding across the Ohio River Valley. And also this was consistent with La Nina as we transitioned from the winter to the spring. So this 500 millibar pattern, very typical for kind of late winter background climate state of La Nina, with the subtropical ridging over the Gulf of Mexico, southeastern United States, amplified troughing over the western U.S. So a good signal for a nearly stationary frontal boundary, lots of moisture to work with. So week 2 precipitation outlook was calling for elevated chances of above normal precipitation. So given the background climate state, that 500 millibar height pattern and some tools as well, we did post a slight risk of heavy rain, which ended up coinciding pretty closely with that axis of 2 to 6 inches of rain during that 1 week time period. And also we had flooding posted across the lower Mississippi River Valley. And that's all I have. So once again, thanks again for the opportunity to discuss our week 2 hazards. Guess I'll hand it off to Melissa now, and then we can wait on questions.
All right, thank you, Brad, and thanks everybody for attending and listening in. My name is Melissa O from the Climate Prediction Center, and I'll be talking about the probabilistic extremes tool that Brad was showing a little bit more in depth and give some background, and also show the public version of the tool. So here's my outline. I'm going to give a little bit about the background motivation for the tool itself. Talk about the PET, that's the acronym I have so that it's not as long to say probabilistic extremes tool. Discuss the data sources that we have for the tool, the methodology, also some format interpretation of the tool, and how we use it in the Week 2 US Hazards Outlook, which Brad did cover. And then talk a little bit about the ongoing and future work for the extremes and hazards. So the background for this was that we used to do the days 3 to 7 hazards as well as into day 14, but WPC has taken over the days 3 to 7, and now we focus on the Week 2 hazards outlook. So with that, we shifted from having a deterministic format of the hazards to primarily probabilistic. Of course, we still have some categorical formatted hazards, but mostly probabilistic format. So, and then another important thing is that raw probabilities from ensembles often produce probabilities that are too high, and therefore those are unreliable probabilities. So we needed to have a tool that's calibrated where we post-process the probabilities so that it's a bit more reliable. And in terms of the strategy for creating this probabilistic outlook tool in support of the hazards, we did a phased approach for each variable. So we converted each of the variables, minimum temperatures, maximum temperatures, precip, and wind over time so that we could focus on each in terms of creating a variable that was a model output variable that was calibrated and also verified and also vetted by the forecasters. So some of the motivation for creating this tool was that we needed the probabilistic ensemble guidance to support the Week 2 US hazards outlook. As I mentioned, when we shifted from the 3 to 7 to the days 8 to 14 day outlook, we needed to have it in probabilistic space, and we need it with reliable probabilities. We also needed a tool that put these forecasts into a climatological context, so we needed percentiles at each location. And the reason why that's helpful is that it provides useful context for the relative rarity of an event. It tells you how frequent this upcoming potential event could be. And that helps forecasters understand how impactful an event could be. This also provides additional information to users beyond the hazards outlook. So the public extremes tool allows users and stakeholders to view various thresholds that are not necessarily discussed in the hazards that might be for a specific interest. So it kind of extends the hazards outlook for more specific interests. A little bit about the PET. We have a public and internal version. We've had the internal version for quite some time, but now we have a publicly available version, which I'll show you as well. The public version only currently has the GEFs. The internal version has GEFs in European, and that's due to agreements with the European Center and legal agreements in terms of sharing it publicly. So we had this tool publicly available as of 2018, and it's been running since then. And it has forecast probabilities of exceeding various thresholds. And the nice thing about this is it has thresholds in both percentile space as well as the actual values itself. And the probability distribution that you see with the forecast probability shown, they're built from a model ensemble. So in terms of the public version would be the GEFs. And also, as I mentioned before, the forecast probabilities are statistically adjusted or post-processed, creating more reliable probabilities there. And this is just a sample screenshot of the internal version of our tool. So as Brad mentioned earlier, we do have, we can look at different values as well as the percentiles. So you can see on the right side, the bottom, you can see smart tools. This highlights a combination of where there's the exceedance of a percentile as well as the exceedance of actual value combined is reached. So it's a nice, easy way for forecasters to see where that combination of percentile and actual values might be considered hazardous. So a little bit about the backend data here. We did switch over to the GEFS version 12. We also have the European ensemble data for each of the tools. The resolution is at 1 degree, and the GEFS has 31 members, the European has 51 members in real time. And in terms of the training data, we use a long term of reforecast for both of them. We use 20 years of hindcasts or reforecasts. And these are paired with observations for each of the variables. So listed here are each of the data sets that we use for each of the variables for the max temperature, min temperature, precip, and winds, which I won't go into detail. But these are the various data sets that we used, and we basically pair the observation forecast in the past to obtain our training stats. And then finally, for the climatology data for each of the variables, we derive the historical observations for it. And it's a 30-year base period that we use, the 1991 to 2020 30-year base period. And in terms of the climatology data, it's basically a mapping of percentiles and actual values as well. And there's more details here if you go to the public tools page, which I'll show a little bit later. There's a link that will point to here, and this link at the bottom gives you a description about the tool itself and a little more detail. In terms of the methodology that we have for the PET, we first bias correct. So basically, it's taking the historical observed mean and subtracting it from the historical forecast mean, and you get your bias. And then in the real-time forecast, we subtract that bias. After we do that bias correction, then we do the calibration, which is the adjustment to the probabilities themselves. We pair these historical reforecasts and observations, and then we create a set of statistics. These training statistics are then applied to the real-time data, and then we get a more reliable calibrated data set. So one reason why we use ensemble regression as the technique, which was created by Dave Unger in 2009. A big benefit of this technique is that when you do the training and you get your stats, you can use less members in the training period, which is usually the case when we get a reforecast. It's usually far fewer ensemble members than in the real time. So we can use less members in the training period to get the statistics because we use the ensemble mean to get those statistics. But when we do the stats in the real time, we can apply those stats to each of the individual members in the real time. So we retain more of the information from the real time members. So therefore we get a probability distribution that incorporates more ensemble data. The outcome of this application of post-processing is that we get a fully calibrated probability distribution of the ensemble forecast, with forecast probabilities of exceeding the 19 reference percentiles that we have. So when you look at the tool and when the forecasts look at the internal tool, we see a subset of these 19 reference percentiles. So we do have the option of evolving and obviously looking at other ones and adding percentiles in the future to the public tool as well, which sometimes if a stakeholder finds a percentile or value more helpful, we will go ahead and implement a different or add a new threshold. So the actual values that we see in the thresholds, those are actually calculated by interpolating the percentiles to value. So we're not explicitly calculating the probability of exceeding a value, an actual value like a temperature or precipitation amount, but we're calculating the probability of exceeding a percentile, and then that percentile is back calculated from the climatology to what the value would be. So the thresholds that we have are based on a baseline 15th, 85th percentile, as you heard earlier, since that is commonly used. It's appropriate for a skill for longer lead forecasts. If you go too extreme in the percentile space, you just get much smaller sample size, so you're going to have a lot less skill, and due to sample size there. The thresholds are also based on forecaster experience and consensus across multiple forecasters. Also through discussions and conversations with various WFO and regional input from climate focal points, we're able to kind of get an idea of what thresholds would be helpful in the tool that would support also the US hazards outlook. As all of this is, all the thresholds evolves over time, especially with any changes to what would be deemed impactful to a region. So over time, we continually discuss with stakeholders what they think would be most useful in terms of a threshold. So here's some simple screenshots of the public version of the PET. This slide shows the different thresholds that are currently available on the public extremes tool. So we have 4 different variables. On the top left is the maximum temperature, so you can see the thresholds listed there. For all of them, we have the greater than 85th percentile, and then for the minimum temperatures, less than the 15th percentile. And then you can see the various thresholds that we've selected based on the different inputs that I showed in the last slide. Here's a little bit more information about how we obtain the data and what data we pick out from the model. So for the maximum temperature tool, you can see at the top here that it's daily. So we have the days 8 through 14 separately on the tab on top. So we take the maximum temperature for each of the days, and the bounding period for that is 60 to 60. Similarly, for the minimum temperatures, it's the minimum temperature of that 24-hour period, also going from 60 to 60. For the heavy precipitation, we do 3-day accumulated amounts of liquid equivalent. So you can see there's a window of days 8 to 10, 10 to 12, and 12 to 14. And those bounding periods are 12Z to 12Z. And the reason why we do 12Z to 12Z is based on the what the backend data is supported for. The high wind probabilistic extremes tool uses the maximum 10-meter wind speed over 3 days. So we pick out of the data points from the model over 3 days, we take the maximum 10-meter wind speed over the period. And that's also 12Z to 12Z as well. So here's a little bit about the format to get an idea of how to navigate the public extremes tool. So here's the web page shown on the right that you can access. You can also access this via link on the left of the CPC US Hazards webpage. There's a link to this. On the top, highlighted in red is where that description is that I mentioned, where you can get more information about the tool. And then underneath that, you can see a couple buttons here. Each of these 4 buttons represents a different variable, so you can select the variable. And then below that, you can see the valid dates here, as well as the lead day. And then you can also select your threshold here. So you can see the greater than 85th percentile, 90, and 100 degrees Fahrenheit here. So once you select that, you can also select the lead time, which for temperature is just the daily for days 8 to 14. Another feature is that it's actually global. So the default view is for the US, but you can just use your cursor and drag the map, and you can get data across the globe, which is nice. So this updates daily, and the time aggregation, like I mentioned, it varies by variable. So the precip will have the 8 to 10, 10 to 12, and 12 to 14 day lead. A little bit about the interpretation. So for an example, for the screenshot I have here, across the West, you can see this heavier border contour here. So areas enclosed in that, there is at least a 20% chance of maximum temperatures exceeding the 85th percentile on day 8. So you can look at what you've selected, and that's the probabilities of exceeding the threshold that you've selected, where the percentiles were based on the 30-year climatology. And also over here, you can see embedded within that 20%, you can see these smaller areas of 40% over California and parts of Idaho, where these probabilities are greater than 40% of exceeding the 85th percentile. So this is kind of the areas that the U.S. hazards forecasters would look at to highlight a moderate risk, whereas the 20% line here would typically be where we would look for a slight risk of a heat or max much above normal temperature. So you saw some sample cases in Brad's presentation for the hazards. So the U.S. hazards forecasters use this routinely. It's the primary guidance for supporting the risk levels. So the internal version of the PET does have more thresholds than the public, and that's simply because due to the resources, the way that it works, it is a lot more intensive in terms of computational to support as many thresholds on the public version. Although in the future, if some of the software changes, it's possible that we could put more thresholds on as well. So forecasters use these two probabilities that greater than 20%, so 20 to 40 would typically be the slight risk, and then between 40 to 60 would be the moderate risk, and then if it exceeds 60%, we would potentially issue a high risk for that hazard. Of course, forecasters also use subjective temporal and regional thresholds, as we mentioned. Much of that can be very event-driven and also based on the time of year and location of the country. And again, at the bottom is the Smart Tools feature for the forecasters, where we can see highlighted in gray as well as yellow. It's an easier way for forecasters to distinguish where both the percentiles and the actual values may be deemed hazardous. So some ongoing and future work with extremes and hazards. We're currently involved with NCAR, their model evaluation team, their MET verification project, trying to get some of our forecasts into the MET tool, including the US hazards. So trying to do some verification of the US hazards based off of the NWS watches, warnings, and advisories maps, considering that sort of as our proxy for an observation. So what you see here is just an initial sample of what the object verification output from the mode tool from MET can look like. So you can see our outlook on the right map here for much below normal temperatures. And this is just translated into the tool, into the verification tool, into these object shapes. And then you can get a big range of different statistics that can tell you about the pattern matching, the shape shift, potentially how much of your area is covered that verified. So there's a lot of different statistics that get output. And at the current phase that we're at now, NCAR is working with us to figure out what metrics from verification would be the most helpful for forecasters and what would provide the most helpful information based on this verification. Some other ongoing and future work is that we're working to draft a journal article supporting the week to use hazards outlook as well as this tool. We're also working to get a Canadian model version into the PET with one caveat that we don't get max and min temperatures. We only get T means, so that poses a challenge for getting that variable tool. We'll also be working on a skill-weighted multi-model tool. So based on the skill of each of the models, determining how to weight the probabilities. We're also going to be doing further verification in addition to the hazards verification, further verification with the GEFS 12. And ongoing is that we add thresholds based on stakeholder feedback, which changes over time. And also we are working on the addition of a probabilistic snow tool to the PET. And with that, thank you for listening in. This is the link to the probabilistic extremes tool. My contact is here if you have questions or comments on the tool. And these are just some of the references on the bottom for some of the work that was done. So with that, thanks, and that's all I have.
Thank you very much, Melissa and Brad. We really appreciate it. I will turn things over to Jenna for our questions section.
Okay. Thanks, Andrea. And thank you, Melissa and Brad. Brad, I'm going to unmute you because I think I had muted you earlier, just so you can answer some of the questions. We have at least one that came through the chat box. So again, if you guys want to ask a question, submit it through the chat box. And then I have a few more from the panelists. Okay. So the first one's a little rather long, so I'm going to read it. I'm not sure who this is directed towards, Brad or Melissa, either or can answer. Joe from WFO Duluth here. We really love using these products for anticipating extreme cold events and sometimes for snowfall precip events. However, sometimes the graphical maps can get messy if there are multiple hazards going on. The experimental breakouts by type are good, but would prefer to see these as shaded areas on the map instead of the outlines. Essentially looking for ways to better localize the message and just focus on the local hazards upcoming. Are there any improvements planned for visualizing the hazards outlooks? There is a service on IDP GIS, but this is limited due to how the various elements are combined and the lack of experimental probability maps. Thanks. So I know that was a little bit long, but either one of you, would you be able to respond?
Brad, do you have any comments on that?
Yeah, I know we have, I mean, there's the static images that just have the outlines, but we also have the GIS overlays. But yeah, Melissa, do you know of any future work with that? Or
Sure, I do believe that there was, I think that there are filled in shaded maps being created on the back end. I think that was for a specific stakeholder that requested that. And you know, obviously there are issues with overlapping shaded on a static map just because obviously the colors can cause issues, especially for web compliance. But if you do have any interest in seeing some shaded maps or suggest some sort of format, I would say email either me or Brad, and we can certainly discuss this with our managers as well.
Okay. All right. Thanks for that response. Okay, I have a couple more coming in. Let's see. I really like that you guys have pushed the envelope into week 2, but I think the current notification method causes delays. CPC emails Andrea at Western Region, then Andrea forwards the email to the climate focal points, who then forward it to the staff. The process can take a few hours, but it may take a few days if someone's on leave. Can we develop a better method of alerting WFOs that they're in an Outlook area of concern? And so, Andrea, you might want to chime in on this as well.
Yeah, yeah, we have talked about that internally at Western Region, but you know, maybe there's a way that we could involve the rocks in this as well. CPC does copy the rocks, and I know when I'm gone, that the rock does pick up that that duty. Whether or not it's always perfectly done, probably not perfectly, but yeah, maybe we could explore some things. The thing that has been suggested to me in the past is that maybe CPC come up with an email list. I just think that would be really hard to do. because you know, they're slicing and dicing, so they're not going to want to like notify everybody. You know, whereas I know the region I'm in very well, and who I should send it out to. So yeah, maybe that deserves a little more checking. And I'm not sure, you know, outside of my own region in the West, how that's done elsewhere. So definitely something to think about. And I know that my counterparts and I, along with Jenna's group, we have a face-to-face meeting coming up in the fall, and that might be something that we could discuss with our CPC counterparts who will be attending with us.
Sounds like an action item for me. Thanks, Andrea.
Yeah, sorry, Jenna.
I'll put that on the to-do list for our agenda for the SPT face-to-face. Okay, the next question, actually, we got two of the same question. Is the internal week 2 tool available for WFO use? The one with the European model.
It is not. This is actually within the firewall of the NCEP building.
Oh, okay. Okay.
I'm not sure there'd be a way to do that.
Do people VPN into that, or no?
Yeah, you would need to VPN into it. It's on our CPC internal server.
Okay.
So I don't even know if all of NCEP can see it.
Okay.
But yeah.
Okay. Let's see. Another question for Brad. Are there any plans to eventually add severe weather to week 2 hazards?
Yeah, so yeah, there's certainly some thought with that internally at CPC, working on a severe weather tool. But there's also I mean, there's obviously patterns that are that you can identify, amplified trough upstream over the west that are typical for severe weather outbreaks downstream over the plains and Midwest. So yeah, we're certainly thinking about that. That's something that management between CPC and SPC would kind of need to work out. But yeah, that's potentially in the works in the future. Yep.
Okay, great. And then my next question is from Melissa. For precipitation, is there enough spread in the GEFS and European ensembles systems to capture all extreme precip events?
I would say it is highly based on how many events you have in the past. So it depends on what percentile I would say you're looking at. Obviously, that's why we kind of cut it off at 60. For example, like winds, we notice that it's even less reliable above 60%. So that's why we don't show a high risk. So it's kind of long-winded, but I would say the reforecast provides the most important piece of calibrating it. So like 30 years, you have about 30 years where you can calibrate the statistics and adjust your real time. But in terms of the real-time forecast, I'm sure we could evaluate the actual ensemble spread itself. But, thinking more about the events and calibration, there are just some events that you cannot capture within 30 years, unfortunately, which is also why we use the 85th percentile, not, for example, the 98th, just because there's just far fewer events in there.
Okay, thanks. So I think I have one more question. I don't see any more coming through the chat. Let's see. So when does CPC switch from saying well above normal temps to excessive heat? Is there a difference in your criteria when this is switched? Were you going to answer that, Brad?
Yeah, so typically we use excessive heat during the warm season, the summer, when the WFOs are, they'll more often highlight excessive heat warnings, watches, that type of thing. And much above normal temperatures would be used outside of that time.
Yeah, I would add that the only exclusion would be that, for example, in Alaska, we typically would use much above normal temperatures instead of excessive heat, just because if we do put a hazard up there, it's most likely not going to hit a typical heat threshold that people would think of. So that's kind of the exclusion. But just we try to make it a bit simpler, like Brad said, and for the majority of cases, just switch from much above normal temperatures to heat, just for easier messaging.
Okay, I don't see any other questions. So I just wanted to briefly mention before handing it back over to Andrea that we did record this webinar and we will be posting it on the Climate Services webpage. Let me put the link in the chat real quick and send it out to you guys. And it'll take maybe a day or two at least, because Jim helps us post-process these and put them online, and he's a little busy with the webpage transition right now, so hopefully by Friday or maybe by Monday it'll be online. And we'll send an announcement once it is online. I'll send it over the listserv. Okay, thank you, Melissa and Brad, and I'll hand it back to Andrea to close it out.
Yeah, so again, just a big thank you to you both. I really appreciate you doing this for our field offices. And if you have additional questions, they both said they're willing to take those, so please take advantage of that. And then for our next webinar, we're going to move to winter. So we will look at winter teleconnections, and that will be both September and October, and that will be Stephen Baxter. And then we will switch to the stratosphere with sudden stratospheric warming, and that will be Amy Butler from Ezreal, and that will be in November. So some nice cold seminars coming up starting in September. So thank you, everyone, and have a great rest of your week.
Great, thanks, Andrea. One more thing, I did put the link to the document that I have in Google Drive, where I have all of the seminars listed there for all the future ones. You can click there to register. All right, thank you guys. I'll end the webinar now. Have a great day, everyone.